Alright, welcome to Geometry 6-2. We're looking at surface areas of prisms and cylinders. And before we get in the workbook, we learned about just what a prism is. And a prism is when you have a polyhedron that has two congruent parallel faces. So you can see these two triangles are congruent, they're parallel. These are the bases. This is what you name your prism off of. So this, in this case, this is a triangular prism. And the other walls here, or faces, so the ones that are going around it, not the top and bottom, but the ones that are around, are called your lateral faces. But now that you know that, moving into our prisms, the first definition that we're looking at is going to be altitude. And the altitude of a prism is a perpendicular segment that joins the planes of the bases. And let me say this again, and I'll point it out to you. The altitude is a perpendicular, so here's a perpendicular segment that joins the plane, this plane and this plane, of the bases. So again, this is what you need to write there. A perpendicular segment that joins the planes of the bases. So this is on one plane, this is on another plane, and this segment here, not this bottom one, but just this segment here is your altitude. The next thing we're looking at is height. And the height, let me just show you this example too. So you have, let me color this in for you so you can see exactly what's going on here. Okay, let's say this is, and then there's one down here, that's your base. So if these two are your bases here, right, the altitude, again, needs to connect these two planes. So it's a perpendicular segment, so that joins this plane to this plane. The height is real simple. The height is just how long that is. It's the length of the altitude. So if, this height here, let me change this back. If this is 7, this is 7 here, then the height would be 7. So it's just the length of the altitude. Lastly, we just want to talk about one or two more things. The difference between a right prism here and an oblique prism. And you can see that there's some differences just visually. And the right prism is probably the easiest to identify. And it's when you have, again, your lateral faces are the ones that go around. And when you have a lateral face that are all rectangles, so you can see this is a rectangle, this is a rectangle, this is a rectangle, right? And that one of their edges is your altitude, then that's a right prism. So basically it's when you have one of these rectangles, which is your lateral face, that joins the bottom base at a right angle. It's perpendicular. So when you have a lateral face that are a rectangle and the edge is the altitude, that's when you have a right prism. I'll just slow down with the definition one more time. A right prism would be a prism where the lateral faces are rectangles. The lateral faces are rectangles. And a lateral edge is an altitude. So a prism where the lateral faces are rectangles and a lateral edge is the altitude. Let's look at the oblique prism. Oblique prism is where some or all of the lateral faces are not rectangular. So you can see this face, and I'll use a new color here. This face is a parallelogram. It's not a rectangle. This face, well, this face is a rectangle, but this back one here, again, this back here, this one in the back, is not a rectangle. So an oblique prism is where some or all of the lateral faces, so just some or all of the lateral faces, are non-rectangular. Forgive my handwriting. Rectangular. All right, let's move on to the next page. On the next page, we're looking about using nets to find surface area. And a net is kind of just an unfolded version of this shape. So here we have a triangular prism, and a net is going to be an unfolded version. So for example, if I unfolded this, it would look something like this. We have, and I'll start with, we have this base down here, right? So it's two-dimensional unfolded. So we have this one, and then there's triangles on both sides of it, right? And then you also have this, we'll call this the right wall, and this other wall, your lateral sides. And why is this important? Well, when you use nets and you draw nets out, it really helps you see the surface area a lot more. And so, again, the surface area is what is the area of all the outside faces on and bases that make up this prism. And so now that we have our net, we can see exactly that. In this case, there's 5 shapes to do it. And that makes this a lot easier. We're not going to go ahead, we'll solve one for surface area later in this. In order to do this too, we would need the height of a triangle here in order to solve this one. But you could find the area of this rectangle plus the area of this rectangle plus the area of this rectangle plus the area of these 2 triangles would be your total surface area. Let's look at the next slide. So in your book, you can see here it says, the lateral area of a right prism is the product of its perimeter of the base and the height. And let's look exactly what that's saying. So the lateral area of a right prism, which we have here, okay, is the product of the perimeter of the base, so that would be this, times its height. Now, how would that give us all the blue around? Well, first let's just illustrate, what this looks like. And what this looks like is you have 4 walls of a box. Okay, this is your lateral faces, and then you have your bases here, right? And if we unfold, and it's what's the lateral surface area? Well, the lateral area would be this unfolded. So it's this side, the back side of that, and then this side that we can't see here. And if I unfold that, you could see I have my side, my longer side, my short side again, and my longer side. And what's the area of all this? Because this is your lateral area. Well, the area of all that is going to be the bottom, which is the perimeter, right? If we unfolded it, it would become this bottom times the height, and that's how we get that. So again, the lateral area is going to be the perimeter of the bottom, because this short side and then this long side, this short side and this long side is here. Long, short, long, short. We've just unfolded this into a long, long rectangle. Times the height, which is right here, that's going to give you the area of your lateral faces. Moving along just a little more, what's the surface area of a shape? Well, the surface area would be the lateral area plus the area of the 2 bases. So in this case, if you wanted to find the surface area of this rectangular prism, you would find the lateral area, and then you would add that total area, so this area, plus the area of these 2 bases, and that would be your total surface area. Let's look at the next slide. Well, let's go ahead and solve for this one. So one thing we are missing is just showing that this is a right triangle here. So we have height. These are right triangles. Well, again, to solve, we need, what is the lateral area? So the lateral area is going to be, and when I say lateral area again, we're looking at this face plus the face in the back plus this rectangle back here, this one. Okay, so there's 3 rectangles there. And to find that, based off our last slide, it's first let's find the perimeter of a base. I shouldn't use that notation. The perimeter of a base times the height of it, right? So the perimeter would just be 3 plus 2 plus 5. So that's 10 centimeters. Times the height, which is 10 centimeters, means that our lateral area equals 100 centimeters squared. And again, from our last slide, just back here, we said it's the lateral area plus the surface area of your base. So let's move back. So we found the lateral area, and now we need to add the surface area of these 2 triangles. Remember, the area of a triangle is 1/2 base times height. So we have the base, the height of our triangles. So that's going to be 1/2 times 2 times 3. Half of 2 is 1. 1 times 3 is 3. So each triangle is 3 centimeters squared. And we have 2 triangles, right? 1, 2. So total, we have plus 6 centimeters squared. So the surface area of this equals 106 centimeters squared. It's pretty easy. Again, you just find the lateral area, and then you add that to the area of the 2 bases. And that's using formulas to find the surface area of a prism. Lastly, when we look at cylinders, it's the same thing. But what is our lateral area on a cylinder? Well, if I slice this down, right? Imagine a soup can, and I cut the label right here, right? When I start to peel this back, this shape, what's going to roll off of this is going to be a big rectangle, right? And to find the surface area of a rectangle, again, it's just base times height, right? So in this case, the cylinder might give you the height, might say this is 10, right? So, all right, cool, that's 10. But how do I find this? Well, again, just to show you visually, if I were to wrap this back around, it's going to be the circumference of the circle. So, depending on what it gives you, if it gives you either the diameter or the radius, the circumference of a circle is just the diameter. So let's say this is 5 times pi. So this could be here 5 pi. Or this one too, same thing, 5 pi. So the length of your rectangle is the circumference of the circle. And then you can know that this so far is 50 pi. The area of a circle is pi r squared. So in this case, it's pi times 5 squared. So each of these would be 25 pi. This one is 25 pi. So the area of this cylinder would be your lateral area, you have 50 pi, plus the two areas of your circle, so plus another 50 pi, equals 100 pi, and then we can multiply that by approximately 3.14 to give us an approximate value of 314. Okay, that's it for this unit. Good luck. Read the problems, follow the work along, and see you in the next unit. Bye.